three element one location, right? But there is not like that. Just you have to break this link. Instead of that, you have to establish this link. That means this node will point to this new node, and this will contain the address of this node. So only this change we have to do. We have to break this link, because the next node after this will be this, so it will point to this new node, and new node the next part will point to the previous node which was after this node. This node will be pointed by the new node pointer. So in this way the linked list addition is being done. Now, so this is a linked list operation, how insertion takes place. Now, linked list operation insertion can be three different types. For example, suppose we want to insert the new node at the beginning of the list. So it will, the head node, this will become the head node in that case, and it will point to the previous head node of the list. So it will be inserted when it is inserted at the beginning of the list. So this new node becomes the head of the list. And so, and another case it may be that the new nodes will be inserted as an intermediate node, or the new nodes will be inserted as the last node of the list. So instead of null, it will contain the pointer of the new node, contain the address of the new node, and this new node next part will contain a null part. So in case of insertion in linked list, there are three cases, three types of insertions are possible. Number one is that add at beginning. Number two is equals to add at last. And number three is add after loop. Add after loop. What is this loop? That means suppose after two nodes you insert the new node, or after three nodes you insert the new node. So this type, that means add as an intermediate node. This means add as an intermediate node. And add at beginning means add the node which will be the head node of the modified list. And add at the last node, that means the new node will be inserted at the end of the list. So now we will see how these three insertion operations are being implemented. So in that case, actually when we will implement this, we will use a pointer, because suppose, what is that? Suppose first of all we want to implement add at beginning. That means suppose this is a pointer which is pointing to the head node of the list. So this is a pointer which is pointing to the head node of the list. Okay. Now suppose this pointer has reserves a location, suppose 1000. So now suppose this head pointer is null. That means the list is empty. So if you want to insert a node, that will be inserted as the only node, that means at the beginning of the list. So in that case, the head pointer which will be pointing to the head node of the list, this head pointer will change. So instead of null, it will then contain the address of the new node. Suppose this is the new node which we want to insert, which is suppose at location 50, and this is next part, which is suppose at location 52. So enter location, this is the enter node which will be head node of the list, because there is no element in the list. How to find out whether the list is empty? If the head pointer which is pointing to the head node is equals to null, that means the list is empty. In that case, what we will do, suppose the address the address to this new node is suppose stored in a variable node pointer. node pointer which is stored at location, suppose 2000, which contains the address of this node, which is 50. So now when this node will be inserted at the first node of the list, so in that case, instead of head pointer containing null, it will contain 50. That means it will point to the head node of the list. So there will be a link will be established. This link will be established so that the head pointer points to the head node of the list. So in that case, we are changing the value of the head pointer as these insertion operations are done within a function. So within a function, this pointer value is getting changed. So to reflect back this change when we are outside of that function, we have to pass the address of this pointer. So for that, we need to introduce another pointer which is double pointer, head pointer. That means which is pointing to this pointer, which contains the address of the first node of the list or head node of the list. Suppose it is stored in location 3000, so it will contain the address of this pointer, that means 1000. As we are changing the head pointer value and as this will be done by a function, so to reflect this change outside of that function, we have to pass the address of this pointer. So in that case, we need a double pointer, head pointer, which will store the address of those pointer which is pointing to the head node of the list. So this is required when we are inserting at the beginning, because when we are inserting at the beginning, the pointer to the head node always getting changed, and to reflect that change outside of that add at the beginning function, outside of that function, we have to pass the address of this pointer which is stored in another pointer which is head pointer. So in this way the operation to be done. And if is head pointer equals to, so first we have to check. So what we'll write, so we have to pass a parameter which is double pointer, head pointer when calling the function for add at the beginning, and we have to pass the value that is num, that value we want to store in that new node. So what will be the declaration of the function? Now, it does not returns anything, so void add at beginning. And what we are passing? We are passing the parameter is passed is a double pointer which is head pointer. So which is